Yeah. Thanks. All right, thanks for your time. I really appreciate it. Really awesome to be here. Really awesome to see so many people here today. I'm going to try to do the best I can to talk in a very simple kind of way for someone that does way too much reading in the last few days. So if you've noticed I look very tired, it's because I actually am tired and barely slept. But with that, I wanted to talk about some of the things that I'm doing right now that I hope are interesting to everyone. They deal with specific items that are happening on a worldwide basis that interested me as a security startup, and I wanted to make things really easy and understandable for folks. Unfortunately, when you're in this type of environment, it means that the load of work that you have to get to a point where you understand something is about like this. So you go through, I spend a lot of my time going through research, doing research, trying to understand what people are trying to say and then put that into more practical terms. So with that, Thomas and the bots. And I just want to start talking about algorithms, open source mathematics, because I hear a lot of different folks talking about how their algorithms are proprietary and how they created something new. And when I asked them if they knew who Thomas Bayes was, they couldn't even give me an answer. So with that, I thought maybe it would have been interesting to talk about what Bayes' theory is, what does it handle, what are the different ways, shapes, and forms that we can use data in all kinds of different ways, shapes, and forms, and turn it into something that's really easy and that we can relate to, right? So I hope that's of interest. So with that, who am I? I think the name says it all, right? So I had a trail of tears, started off as an administrator, worked my way up to architect, did a whole bunch of different stuff, sold for different security companies. After doing 20 years of SIEM, IDS implementations, you learn a lot about what doesn't work and the very few things that do work. And then you try to help people understand, okay, well, why does something work or why doesn't it work, right? Specifically for the topics of collecting information that a SIEM, IDS, and IPS can collect. A lot of you folks that have done this before realize that the A&O of doing good systems is how you create the rules. And the way you create the rules is by understanding what information you want to collect and then start standardizing, categorizing, putting the data into different pots that you can then take and analyze for what you need the data to tell you to do, right, in a simple way. So with that, I do a lot of security and business impact analysis research. So I want to understand, on the one hand, the three cybers, which is espionage, warfare, and crime, how that technology mixes and matches into different domains, how this influences the different types of attacks and threats that we face every day, and why can't we, for frig's sake, learn from the things that we've done in the past, and why do the security technologies that we see not work anymore, right? And the more and more I think about this, the more I move into a model that says, specifically, we have to understand the stuff that we're looking at very quickly and then figure out what to do with that, right? So I started off by building stuff. I thought I could do something better, and hopefully I did. I built a sensor system and a security appliance, which was a very small system. I started off with Raspberry Pis, figured out that they were not exactly what I needed them to do. Every time I built up a sensor in the first phase, someone came along, pwned the crap out of the box, and then it was unusable. Then I figured that maybe implementing some security mechanisms on the box, the sensor that I'm using, might be a good idea. So then I started getting smarter. I implemented a sensor system that had IDS, IPS, firewall, IP chains, all that kind of stuff on top of it. Then, wound up into a security appliance. I hate using that word, but that's what it is. That you then can use to monitor attacks in real time, figure out what the hell's going on, use simple tools like Mmap to scan what ports are open. For instance, if you have a DSL modem, 7547 I think has been in the news. If you guys have DSL modems, like for instance Telecom, there were some interesting DDoS effects that happened with BusyBox-based Linux and hard-coded passwords, which is never a good idea. So that kind of stuff. Collecting information about how you understand what that actually means, where the attacker's coming from, how can you defend against it. And then just keeping all that information simple, usable, and valid. That last piece took me a long time because you literally, even when you start up with PCAPs, when you're doing classical network monitoring, you capture PCAP files and you take a look at literally gigabytes of data to understand what the heck is going on. You have indicators of compromise which tell you something could or could not be an aspect that is good or bad. And then the question then becomes, how can you build something to automate this because you just don't have enough time in the day? and the amounts that you're collecting are growing and growing and growing, right? So then at that point, you get to the stage where you ask yourself, okay, well, I'm collecting all this data. How can I use it in a way, shape, or form that is usable to me and everyone else? So for this, the issue statement was a few months before the elections happened back in November in the US, I started seeing a trend of things happening where a lot of Twitter users were being generated dynamically, I believe or assume. And then the question for me was basically figuring out how can I detect, for instance, on social media if a user was legit or not. It sounds stupid, it sounds easy, but the more you take a look at this type of issue and the different types of social botnets that are out there, the tougher it becomes, right? So what categories do you use to classify if someone's human or non-human, right? How do you collect the data about what is human, what is non-human? And then how do you crunch it into something that is usable to tell you what the probability of a Twitter user being human or non-human actually is, right? So, get to that. Okay, so that was that. Then the question was, once you start collecting information about all these different users that were cropping up and following you, the next question was, okay, well, there was something called hybrid warfare. It basically means that we use different types of technology, unfortunately new technology in some cases, by nation states to trigger or track and disrupt certain actions of another nation state. Now then the question was, there's so much political debate going on about this, and I wanted to completely remove myself from that because I tend to get focused on some things very passionately. And then I thought, well, just like some people were saying, hack your own mind, I figured if I could separate the emotions from the actual data that I'm collecting, maybe I can get to a state where I have an answer that is not biased by my own emotions and what I want the data to be, right? So then taking a look at things like fake news spreading, public sentiments, how that actually influences stuff, etc. And then the last piece is how do you defend yourself against stuff like this happening? So if you use this data, you collect this data, how can you find out who the actual enemy is? Can you find out who the actual enemy is? And that's a very difficult question. Well, it's not a difficult question, but it's a difficult answer to find because these actors, they're interchangeable. Some things look like this, but maybe it's something else. You have to track a lot of data over time that will give you a prediction of what you think is happening actually is happening, right? Hopefully this is logical to everyone. So with these types of questions going around in my head at the same time simultaneously, a few issues came up. So the first issue was, what kind of data do I need to collect? What type of factors classify, or what do I use to classify the data that I'm collecting? What types of factors do I look at? How do I define what a class is? And then how do I use the definitions of classes and the information I'm collecting from these classes to say if something is 1 or 0, right? So in this case, are there algorithms that I can use that can make sense of this? Are they proprietary? Are they open source, right? And then how do I put all this stuff into what we call a classifier, which can then tell me if there's a sign of a botnet or not? And how do you make this scalable? Right? So, some of the theory assumptions that I was working on while working on this was 1 is equal to a social bot. 0 is human, or a real person, or whatever is close to what a real human is, right? From a mathematical perspective. And then the last result is 1 and 0, which means I've done everything wrong and I have to go back to the drawing board because either the algorithm was not correct, my data was incorrect, something was not working, and I need to figure out how to get it to work again. And you spend countless hours doing this. I mean, we're talking about hundreds of hours. Even though there's a lot of PHP frameworks and also Python, I use Python a lot, there's still a lot of tweaking that you have to do and ask yourself the questions before you work on the code and modify it for what you need it to do. I mean, it's out there, it saves you time, but you still need to go through a lot of this work yourself. So, and then find out the likelihood of 1 or 0. in a dynamic environment where things are always changing, botnets that use connection procedures that are P2P, DNS flux issues where domains are popping up left and right and they interchange very quickly. Then once they're there, then they're gone again. How do you collect consistent data? How do you find out and track what the hell's going on, right? So we'll start off by talking about algorithm basics, Bayes' law. I don't know if anybody knows that, but I plan on talking about that, so hopefully if you do know about it, just be quiet. Okay, so Thomas Bayes was, I believe, around 1758, if I'm not entirely incorrect, around the 1700s, was in England, was a pastor, which was really awesome when you consider at that time there were no computers out there, and this guy actually created something extremely useful to us that we use in a lot of different tools, right? So what I want to say about this is that this algorithm has been around for a long time. Anyone that uses this algorithm doesn't have proprietary algorithms, in my opinion, because mathematics I would consider is open source, and this already exists. So this is one of the reasons why I thought talking about this would make sense, because a lot of people are scared when we work with data. Okay, well now I have to ask a company A or a company B because they say they already do this and it's proprietary. But once you start digging into mathematics theory, which doesn't take too long, you find out it actually exists for hundreds of years and it's not theirs, right? So in this case, we're talking about probability theory and statistics. Thomas had a friend who liked to gamble. And they just wanted to find out if they could figure out what the probability is if you roll a dice when you get to, a specific number. And they kept on rolling the dice, writing down the results, and then he created, this mathematical principle in that he said, okay, well, here's Bayes' theorem. It's a law and a rule, and it just basically says that we use evidence to estimate if a degree of the belief of a possible outcome will happen or not, right? And there's different variances of this, but at the end of the day, if I roll the dice often enough and I collect enough data, then I can take a look at, based on past events, if the likelihood of something coming up with the next roll of the die will be a 6, a 5, a 4, 3, or whatever, based on the data, right? So, based on that principle, my adaptation was in Bayes' theorem and algorithms that are based off of that is, you want to know the probability of something being what you think it is based on a mathematical principle, which is based on facts and data sets, right? Rather than on what you feel or what you want to be true, right? So taking the emotions out of something, interpreting the data in a way, shape, or form that makes sense, and then extrapolating the characteristics of the data that you collected and then figuring out what you're looking at, and if it's classified as 1 or 0. So when you collect that data, you start to build a model that you can use to do different things on. You can calculate means, you can calculate different variances of something happening, why it's happening, etc. You can start calculating traits, and you can use these traits to classify something into groups. And then after you have these groups, you assign variables that are then used to calculate the probability of something being A or B based on that data, and the likelihood of A or B being relevant to define if something is A or B. Everyone understand? Yeah? Yes? No?
1 or 0.
Yeah, it's a very complex way of saying is something 1 or 0, yeah, basically. But yeah, just, okay. So in the naive Bayes theory, this is a bit different. So here we're using probabilities of each attribute, that factor or indicator of X or of A, belonging to each class that will then be used to make a prediction. So in this case, we assume the probability of an indicator or attribute of something being 1 or 0, yes or no, in this case, human or bot, is independent of all other attributes. Now this is a specific sub-formula and algorithm within the Bayes theory, right? So there's a good representation of this later on. So the question that you want to answer, human or bot, has all these different factors, characteristics that you start to collect in data, which will then lead you to the answer if something is human or not, right? So the probability of a class value, given that value of an attribute, is referred to as a conditional probability. So when you take these conditional probabilities together for each attribute, for a given class value, then you have the probability of a data instance that belongs to that class. So if you collect enough information, you have a trait, you're collecting a lot of information on the trait, you can verify that this information tells you that that trait is cool. That's what you can use to figure out if someone is a human or a bot. If you have multiple classes, multiple attributes, that adds into giving you an overall probability of what you're looking at is or isn't human. So within these algorithm categories, we then have constraint-based, which means estimate from the data whether conditional independence between the variables hold via statistical or informational theoretical measures. And you also have a more efficient mechanism than just a purely score-based approach, right? So if the samples are large, then this is an important factor. Now, if anyone's interested, we can talk about this in more detail about the sub-algorithms, but that would be constraint-based. So in scoring-based, you identify a network that maximizes the score function, indicating how well the network fits the data. And then you have here different things like greedy, local, or heuristic search techniques, such as hill climbing or simulated annealing, et cetera. And then you have on the last piece a hybrid or a mixture of both, right? Scoring-based is used quite often. Constraint-based is used a little bit less so. It always depends on what data you're collecting and what answer you're trying to get. Then at the end of the day, we choose the algorithms in order to make a prediction of something, right? I'm getting to the point. It just takes a little while to get there. Sorry about that. So predicting future based on past observations lends itself naturally to applications requiring predictive analytics, something you guys have heard before, huh? So not a new concept, one thing. So in this approach then for predictive analytics, belief is updated with new evidence. And this is commonly referred to as the frequentist parametric approach, right? Because the frequency of something will lend to parameters being optimized and tweaked in order for you to get the ideal approach of getting to prediction. So, in contrast, Bayesian with the alternative frequentist parametric approach, then that means models the observations as a physical system whose measurements are not exact and thus needs to account for error. So this is a model that you can use if you're not really quite sure of the things that you're looking at, if they're specific enough or not, or if there's too much of an error and you need to collect more data over time to tweak the model even further. And that does happen if you're not quite sure what data you need and how you're going to be using it. And it happens more often than we may think. Second piece, probability of an event is its relative frequency over time, proportionate to the outcome. So here we're talking about prior, posterior, and the likelihood, right? Which would be then A, B / A times the times P. So I'm not the mathematics professor here, so please excuse me for that. Here we have the model up on the top. I'm not going to explain that right now because we're not in a math class. But suffice to say, prior, posterior, and likelihood, we have the elements of P A, which is the prior. We have P A / B, which is the posterior. And then we have the support of B or A, which then means the posterior is equal to the likelihood times the prior events that happened. In naive Bayes algorithms, we have a slightly different approach. Here I said the answer is the black point in the middle, and then we have all the different sub-factors that we need to start collecting in order to find out if a picture is something or isn't something. So in this case, the classification node, which is the circle in the center, is the parent node of all the other nodes, and that assumes that features are independent of each other. And if you think about it, if you're tracking social botnets or a botnet, DNS traffic can be a certain thing. It's not specific to a botnet. Domain names might or might not be dependent or independent. You don't know. TCP/IP traffic, collecting that going to one or specific hosts and attacking IPs could mean different things. So you're not really quite sure if you can narrow down all these different factors specifically from the beginning as being very, very specific to an indicator of something being human or bot, right? So, and then you collect that numerical data. When we talk about the different types of Bayes algorithms that you can use, you start off with a naive Bayes, then selective naive Bayes, semi-naive, one or k independence Bayesian classifiers tree, Markov blanket-based, and then Bayesian multi-inits. And this is just the growth period that you go through, narrowing, redefining, and tweaking the algorithms until you get to a specific area that's good enough for the prediction of probabilities. So that's just a brief introduction to Bayes theory, naive algorithms, etc. Now we're going to get down to some more of the details. So when you think about the theories, they're important because we need to figure out, if we're going to collect data, what different type of data we need to collect, what can we do with the data, how do we standardize it, how do we scrub it, how do we put it into a system, and then what is it supposed to tell us, right? So in this path, the journey at least that I made, and I think a lot of us are the same, after talking about the Bayes law, it makes you more receptive to understanding, okay, well, do I need a naive? Do I need a neural network? Where are the pros and cons in some of these? What are classifiers? How do I use a classifier? That kind of stuff, right? So this basically helps you answer the question of what algorithm can you use to make a determination or a probability based on the information that you're collecting. So with that, I chose Python. Python, very easy language to learn if you're an idiot like I am. There's a lot of libraries out there, a lot of scripts that you can use and tweak in order to test. There's some really cool references I have at the back if anyone's interested, so you can start doing this yourself. It's very easy, and I would encourage anyone that's interested in analysis and probabilities to take a look at these things. So with that, creating that algorithm, use Python and libraries that have mathematical and computational functions. There are specific libraries that need to be loaded into the script. You take basically a data set in the form of a CSV file or another file. That CSV file has to contain data that is going to answer your question. In this case, you have a CSV file that indicates, for instance, the common example is diabetes, yes or no. In this case, we're using it for botnets, yes or no. Each record in the data set has classifiers that indicate something is human or not. The standard data sets yield accuracies typically to around 70 to 80%. Contrary to belief, I haven't seen 100% in any of the probability-based algorithms so far. I mean, people say they get to 99%, but I personally would question that unless I know exactly what the steps are for the script, how well the data has been pre-qualified, and then go through the numbers and see it for myself. In my case, and in most cases, when you're creating the data sets, about 67% of that data set will be used for training, and approximately 33% will be used for testing. It's a pretty stable common denominator. You can do this within the script itself, and I'll show you an example of that in a minute, which I used for this research. I didn't create that script. I just modified a few things for myself. So in that, an example of a very simple algorithm that you can plug into a web application or to whatever you're using based on Python is importing 3 different libraries. In this case, if you have issues with encoding, et cetera, you can add the additional libraries. In this case, it was importing CSV because I'm looking at a CSV file, importing random functions, and importing math because I'm working on math functions. So here, right now, taking the data from a file or stream, standardizing it so that it can be processed mathematically, turning the data in one form into another, and then converting the attributes loaded as strings into numbers so that it will work, right? So if you try to import information that is not numerical, it's not going to work, right? So the biggest issue that I had in answering a simple question was getting the data to a state in a data set that I could collect in an automated fashion that was standardized enough to run through the script. And that's probably the issue that a lot of us will run into. Because a lot of the data, if you're looking at tweets, for instance, and you're downloading the timeline tweet list or representation of data from a profile to determine whether it's legit or not, it's not always going to be in numerical form, right? So obviously there's an amount of qualification and standardization of the data that you have to do. You have to turn it into a data set that is usable from the algorithm. That was my biggest issue, because I'm an idiot, right? So I need to figure out what I need. So, and then the next step was here summarizing the data. So import data randomly into a ratio of 67% training data and 33% test data from the CSV. And you can download this script and test it yourself. I didn't create this one. This was already there. It was a fantastic way of breaking into this fairly quickly. So here, separate by class, then the separate function, calculating the means and the standard deviations, and then summarizing the results. After that, using the summarized results to calculate the probabilities or making that prediction. And then wrapping that prediction into multiple predictions based on the vectors that you collect, which is this piece. So after that, the last step is then calculating the accuracy of the results that you had. And in this case, here's where you'll have the accuracy. That was the example that you will commonly find here. For def main, you have the file name, which is the CSV file you're pulling in. In this case, it could be whatever you want to. Then you have the split ratio, which is 67% for test data and 33% for the training data, right? And then you plug in, load the CSV, go through the different requirements, and then it'll tell you the predictions and the accuracy, right? And if you have an accuracy around 70 to 80%, it's not a bad thing. It's actually fairly good. With that, some of the research I had to do in order to get to that model, to get to that data set, required some research. And I wanted to go through that very briefly. I have the links for all this research. Is anybody on ResearchGate? Yeah. So if you're on ResearchGate, ping me, and then I can give you guys the links for it because there's some really cool stuff. Now, the requirements that I had for my research is I wanted to look at everything that was in 2016, published in 2016. There were one or two documents that were a little bit older that were really cool, and I think they made a lot of sense. They helped me out a lot. So in this one was really cool and interesting because it's very, very obvious today based on the different types of botnets and how they work. It's not specific to social botnets, but it is still applicable because some of the traits you can use to do the predictions, right? So here we have detection of fast flux botnets through DNS based on Scientia Franca journal from 2015. The authors from Sheriff University, I'm not going to read the names. You have the names here. I just want to give them credit, right? So this was focused on logging benign DNS traffic over a longer period of time. Benign data is obviously long life. The short-term data, which is then botnet traffic, is very short life. If you're using that as the only source of the data that you're collecting, then more often than not, you will wind up with data you can't use at all, right? So this was an interesting piece of research because it highlighted again why things like basic core network services like DNS and the DNS traffic that are going on make a lot of sense to collect, right? So if you have a chance, read that document. It's very good, specifically if you're trying to classify what is a risk or not, or threats. Read the document because the DNS information is something that a lot of people forget. A friend of mine mentioned that last night, so it was interesting. So this attempts to eliminate CDN or content distribution networks that cause domain-based misclassification, right? That'll save you a lot of time. Second thing is, oh, wait a minute, that was a copy, sorry about that. Second one was real-time peer-to-peer, not peer-to-peer, peer-to-peer botnet detection framework. This was kind of interesting because it used Bayesian regularized neural networks. So it used a Bayesian algorithm and it used neural networks. So the neural networks was obviously for collecting the information and learning from attacks, but the Bayesian regularization was used to correct some of the issues that are involved with neural networks, right? Author over here, Narang Hota, 1212. It was actually published in 1212. It came out in 13. And this was focused on detecting peer-to-peer botnet traffic in real time and also logging botnet domains, the short lifespan. And it basically targeted decentralized CNC architecture and put that into the real-time data that they were collecting. The accuracy that they reported was around 97%. But I would have to see it myself to really believe that. Even if it is 90%, it would still be pretty good. With the previous study, their classification success rate was also around 98%. So it appears to be very good. But again, I'd have to see it myself. I didn't see these systems live. Yeah, just the details. Data sets of known P2P botnet traffic and unknown to verify the algorithms and the accuracy. Uses a Bayesian regularization for normalizing data collected by neural network. Looks at over 15 features as an input and a class label as an indication of nature of flow, bot or not. Then it passes on the features of traffic flows to MATLAB Weka API for classification. Right? Then the next one, which is really going to answer the question of why I'm talking now, which I found extremely interesting. The only troubling issue I had was who was financing the project, so I'd use a term of caution, because when DISA and other folks are financing something, just be careful what you do with the algorithms. But then, let me neutralize myself from that political statement. I'm not trying to be here for political statements. Bot or not, the script is on GitHub. So let me see if I've gotten that here. Let me just reload that. Bot or not API, you can also see it here, the HTTP API, HTML, it will talk you through the entire process, what the script does. I think it's interesting to understand what the script does, because when you go to the website, let me just take a look, looks like this. So what the website basically does is all the stuff that we talked about the theorems. There's approximately 1,000 different factors that are collected of different component. Oh, excuse me, it's not showing. Why is my internet not showing? Okay, interesting. Sorry about that. Do I have a split monitor here? Okay, I'm not going to troubleshoot this now. I'll show you guys this. Unfortunately, that's not cool.
You try to turn it on and off again.
Wow, why is yeah, Windows 10. I don't know Windows 10. Anyway, I work with other systems. So in this website here, the GitHub piece will show you the script, what the script actually does. And in this case, let me just go back to my PowerPoint slide there. Oh, wait a minute. Now I know why what the reason is. Let me just do this real quick. Sorry. Here we go. Okay, so bot or not, Indiana University, fantastic work. Guys did a great job. This is the result of a script, which is basically here. And you can download the script and you can do research on exactly what the script does. So here, in case you don't have pip installed and you don't have anything against installing pip, use it. It's your friend. In this specific script, you'll download the specific libraries, JSON, Tweepy, requests, etc. The Twitter API you'll need as well. Everybody, I assume, does have a Twitter account. Even if you're hackers, you can't tell me you don't have it, right? Okay, so does everyone know how to create an app on Twitter? Yes? Because you need these credentials for the script later on. Now I'm going to be careful. If I open up the wrong script, you guys are going to see mine, so I'm not going to do that. I'll show you guys later. So when you create an app on Twitter, and that's through developertwitter.com, I believe it was. Here it is. No, appstwitter.com. Then you can create an app which gives you customer key and secret key, and also the access token and access token secret. This is what you'll need to use to do a bunch of simple data collection gathering scripts. If you guys are interested, I have Python scripts there that I can give you that you can use and test. What these scripts basically do is they help me collect data in an automated fashion when it's plugged into my infrastructure. On a manual sense, what it can do is it'll download the timelines, it'll download information about the Twitter user, it will download information about friends and followers, so that if you're trying to use this information to detect if someone's a botnet or not, God bless you, Domini Patre, there are different characteristics that are somewhat reliant on detecting if someone's a bot or not. They have a high amount of people that they're following, but they don't have a very high amount of people that are following them, right? So friends. If you see stuff like that, those are indicators that we use in this collection pattern to basically map out what the influence is of them, how many friends, followers they have, and then is this an indicator of bot or not. but that website does everything for you in the background. I'm the type of guy that likes to understand what a website is doing. So if you want to download the script yourself, this is the script. It goes through the components. So here we're doing an authentication, plugging in your keys, the access token and the customer keys. Then you're going to take a look at a specific Twitter username in this case. Does anybody work with Python scripts and collecting information from Twitter, by the way? Yeah? So what are some of the issues that you run into? Excuse me? Right. So there's ways to work around limiting that are TOS violations, so I'm not going to talk about that here. But there are ways around that, right? Yeah, I'll leave it at that. Any other issues that we run into? Besides the script, there's a typo or syntax error, something that really is excruciating, which happened to me quite a lot, but that's my name, right? Anyway, so in the next case, after plugging in the screen name, we're downloading the information from their timeline. There are limitations. The limitations are built into the rate limits here. But if you go through the website, bot or not, it will also do that for you automatically, right? Okay, and then in the top, I don't like jumping around, but this is important. We're taking a look at the information that comes back. So here, taking post data in JSON format, which is cool. If you have Elasticsearch, you can pipe that directly into your Elasticsearch server if you're using it. Or you can basically print it out as a CSV and then use that in a database or whatever you're using. I use a combination of both databases and Elasticsearch. There's a reason why he's laughing at me like that. He actually had to help me out with one of the scripts because downloading 20 million IPs from an Elasticsearch into a CSV file is not a good idea.
Not the way you were doing it, anyway.
Oh, come on, 36 hours was fast.
20 minutes is quicker.
Yeah, thanks for that. Anyway, I'm still learning, so hopefully we're all still learning. I'm not the only one that's doing this. But those are the interesting issues that you run into. You start collecting all these different characteristics. And the more characteristics you collect, the bigger your data set becomes. The bigger your data set becomes, the more issues you're dealing with just the sheer amount of gigabytes that your system has to work on. I mean, I have a Debian 64-bit based system that also has clusters. I have 6 CPUs on one machine. In the cluster, I have 12, and I've got 128 gigs. And there's some instances where even these two machines are really pushed down in the knees, right? This is the amount of data that you handle doing this stuff. And if you're working on streaming, you really need to think about what data you really absolutely need, right? So if you can avoid streaming a lot of information, do it. Avoid it like the pest. If you need certain pieces of information, characteristics on streaming, like the tweets, if there's something interesting, then you'll have to basically write them directly into the Elasticsearch, but be very careful, right? Data management is your friend, specifically with sums of data like this. Okay, so that was that. Anyone that's interested in the links, I'll give you those links later on. They're also in the presentation. An example of the naive algorithms are also here for anyone that's interested. Also some of the points about handling data, summarizing data, making predictions, making a prediction, then making multiple predictions, evaluating accuracy, and then executing the script is a very good piece of advice, I would say. In the bot or not, I would suggest that you guys try it out, right? So this one's not going to work on mine because I don't have a Twitter user. This is my conference computer. I don't have any authentication information on this, so I can show you guys on my other laptop later, right? If you guys really want to see this in action. But it's very simple. Just remember the link, Truthy, Indiana, Edu, /bot or not. You just plug in the screen name. And then, for instance, here I took one Wiki News because they were really attacking me quite a lot. It'll ask you for the authentication, which I'm not going to type in right now here, and specifically not on a video. No, ain't going to happen. So if you guys want to try it out, then please do that. You need to log on because it'll authenticate with a Twitter user. Create a testing Twitter user because, like I said, some of the financing for this project is interesting. So don't use your day-to-day Twitter user for this, right? Okay. Let me just see if I forgot anything else. I know I'm a lot faster on this talk. Was this interesting so far? Yes? Yeah, cool. Okay, so then just some schematics. Let me just get back into presentation mode. Okay, cool. So there's the link for the Python script. Started off in 2011. It was updated in 2016. Some of the magazines and articles that they wrote on the research is really interesting. I suggest you download it and read it. They don't require ResearchGate access, so they're freely downloadable. The first one is 6 pages. I have it in the back if anyone's interested in the printed form. The other one was a little bit more. It goes through some of the details. But the synopsis of that is, provides an API for Python that can be used, installed via pip, provides an API for HTTP, sorry about the typo, requires Tweepy and the Twitter API to be loaded in as well. And then depending on if you're using JSON or CSV, JSON, whatever, right? Okay, that was the update. That's the link where you can actually plug in the Twitter user that you want to use. And then some details on that. Generates a probability based on around 1,000 features, which is quite a lot. So network features capture various dimensions of information diffusion patterns. The networks are based on retweets, mentions, hashtag co-occurrence, and extracting their statistical features. So for instance, a botnet will do a lot of hashtags with the same tweet over and over again. Now, if you see that, it's a likely indicator that it's probably a bot. Either that or they're a human, which is close to a bot, which would then be kind of scary. But yeah, let's not get into that. And then extract the statistical features through degree distribution, clustering, coefficients, and centrality measures. Then the user features are based on the metadata related to a specific account. They include the natural language, geographical locations if they're activated, and account creation time, right? So then friends features include descriptive statistics that relate to the account's social context, such as the median, moments, entropy of distributions of the number of followers, the followers themselves, the posts, et cetera, et cetera. And then in the next piece, temporal features are timing patterns of content generation and consumption, such as the rate of tweets and intertweet time to distribution. Then last two, content features, linguistic cues. That's a difficult one. Every quote-unquote social media analysis machine that I've seen in the past, they kind of choke on this specific area. So if you're using an algorithm to detect if someone's human or not, and there's a language, a natural language that is not natural to you, then this task becomes a monumental task. Because then what you need to do in order for this algorithm to classify correctly is you need to have a separate database of natural language for that specific language you're looking at, which will then interpret that correctly. Right? That's a different topic. We'll do that next year. Sentiment features are built using general purpose and Twitter specific sentiment analysis algorithms. Includes happiness, arousal dominance, I'm not going to get into that, and emotional scores, or emoticon scores. So this one's interesting. Botternot's classifier uses random forest and also a supervised learning module, so a type of neural network, I believe. Extracted features are leveraged to train 7 different classifiers, one for each subclass of features and one for the overall score. So there's a classifier for each of these specific components we just talked about. They all get put together into a massive database or data set, which then correlates if that person is a bot or not, right? Okay. Tenfold cross-validation yields a performance of 0.95 AUC, or area under ROC curve. One of the notes they put in, high accuracy is likely to overestimate current performance given the age of training data. So what I've observed in the website and the script piece of this is if some of the information is missing, the accuracy goes down. Typically, if you're missing half of this information, the accuracy at the most will probably go down to around 53%. And with 53% is still more. A human being would be classified as around 10 to 16%, right? So there's a margin of error in this algorithm. It's still not there yet, but it's interesting to use as an indicator of something, a probability, right? So that was. Another piece which is pretty interesting is the Shiny Bayesian app, and that I want to show you if you're still interested. Yes, no, maybe, throw tomatoes. Okay, so this one's also pretty cool too, because then it'll give you an overview of the different types of networks that you can build. And the really cool thing about this website is that you can plug your own data into it and you can test your algorithm. Right, so if you have that standardized data set, you could plug it into this RStudio-based web application. You can also integrate that into your own website, and you can use this to do the modeling, classification, etc. So you got the picture done? And the interesting thing is when you switch the different networks, you'll also see the distribution change here as well once the Wi-Fi finally gets there. Okay, that's just more of a show gimmick thing, but here you have various different options. I would suggest if you're interested in neural networks and also in Bayesian networks to check out this app. You can integrate it into your website. It's based off of RStudio. Unfortunately, the 3D network is Java-based, but yeah. Cool. Sorry about that. Then, no, I'm not going to talk about that. If anyone's interested, I think I'll stop the talk now. If there are any questions, then I'll open up for questions now, if that's okay. Or am I too early? 15 minutes. Okay. All right. Well, let me just take a look here. GitHub talked about that. No, it didn't. But here's another example. GitHub is your friend. This was, I believe, another one. This was the code for the naive Bayesian algorithm that you can download and test yourself in Python. It's based off of a well-known principle, which is diabetes, which is that CSV file that we saw before in the code. Just change that file for the data that you need. So then all you have to do is modify the CSV file that it's pulling in on load CSV. I'll just take where that is. I think I need glasses. What? Yeah, let me just, here it is. Okay, here in the main definitions, that's where you'll plug in the CSV file that you want to use for your classification and then see what it comes up with, right? Okay. And here we have the split ratio. Here's the command load CSV, etc. Last but not least, what is some of the stuff that I'm doing with this that we're learning? If that's okay, I'll talk about that very briefly. Some of the stuff that I'm working on right now is tracking different types of botnets. So these are, they plug into the probability that an asset is at risk or not or compromised based on the data that I collect. So what I'm doing in the background is with a database system and Elasticsearch is I take a look at different types of data, feed them into the system, crunch the numbers, and then I can tell you if you have a specific email or IP or whatever, what is the likelihood that your computer is compromised. So an example of that would be, this is just a test data set just to show you how that works. I'll take a look at, in this case, this test data set. It'll tell me, okay, I found one risk. The likelihood is an additional 20 to 25%, depending on what the risk is. They're scored differently. And then it'll tell me where I found the data, et cetera, and what I need to do with it, right? Okay. To give you an idea of what issues I'm dealing with currently, we'll take a look at data. What I basically have in here is the functions from the script. I have a specific website that handles only data imports. So what I do is if you import a CSV file into my system, or if I automatically get the information through Logstash or something else, then I go through the data, standardize it, and if there are specific columns that need to be resorted, then it will tell me, okay, well, how do I parse what? I'm currently tracking about 12.4 million risks and approximately 11.7 million hosts that are potentially compromised. Everything from DSL routers to classical computers, right? That's just a test data set. Now I'm in the process, in the backlog of integrating another 400 million. After the 400 million is on the system, I'll be surprised if it's still running the way it is now. So it's a small data set. The accuracy that I have right now based on this data set is approximately 75%. If the more millions of hosts that I get into the system, the more accurate the system becomes, right? Okay. I guess from my side, that's it. I don't want to do any. Let me just make sure. Yeah. Oh, lessons learned. Very important. So some of the lessons that I learned, besides the fact that data will explode very quickly before you know it, you have to deal with issues you didn't even think you had to deal with in a very short amount of time. So start with the theory, the understanding of that theory, then what is the problem statement or the idea that you're focusing on, right? I know it sounds obvious, but for me, since I was trying to figure out what was the right algorithm to use, I was focusing too much on the algorithm and not focusing on what I actually needed to do, right? So when I started focusing on what the actual problem was, what I wanted to resolve, then it led me to an algorithm that was appropriate for me to use, right? So decide on the factors that define what is A and what is B. In this case, what's the definition of a human? What's the definition of a bot? Can you collect that information? Okay, what data do I need to collect and to confirm that class, right? Or that factor. Decide on the data needed for the factors of A and B, collecting the data sets. What I forgot is while you're collecting data sets, be very conservative with the data that you collect. In my opinion, this is not a political statement. I'm very disappointed with some of the data that I've seen when I do lookups through the Shodan API. If you depend on, for instance, the Shodan API for the single source of your threat intelligence or information, you're doing something wrong. Because very often, more often than not, the results you get back from Shodan and the reports that you painstakingly have to go through, you'll find out very often that the returning data sets are extremely skewed. You have to do a considerable amount of work, classification and qualification work on those files before you actually think about using them as data sets, right? Just a word of caution, I'm not saying it's bad. I'm just saying if you think you just click download and that's it, that's not it, right? A lot of rework. That was my result. Normalize and QA data sets, that was that lessons learned. So every time you collect data from a specific source, make sure that you are aware that the data has a specific quality, that you validate that that data is actually real. Yeah. Tweak the system constantly. Expect issues. You will run into issues. You will. And then get help when you need some. Okay. One other one. Data sets are not always your friend. Okay. Don't get caught up with perfect. Bayesian calculations are good when they're around 70, 80%. If someone says they're higher than 80%, then my first question is what kind of data are they using? Was the data qualified? What exactly is that algorithm doing? How is it classifying, et cetera? I need the details of that. 100% is ideal, but it's not always achievable. So in this case, since this project of mine is solely financed by myself, I needed to draw the line somewhere between 100% and what's realistic. And when you have your own, when you finance your own projects, then you very quickly get to this point where you need to figure out, okay, well, how good is good enough, right? So big disclaimer on that. Yeah, and that's basically it. I think that's it. Should be it, yeah?
I normally start off with the first question, but my brother from another mother is jumping in right away, right?
So aside from checking that a data set is authoritative, is there any other pre-processing you do to make sure the data doesn't have weird values or null values? Or,
yeah.
And what tools do you use for pre-processing?
Well, they range from using regexit, going through the data sets and finding out if something's amiss, to manual validation. Right now, I'm currently doing a lot of manual validation simply because the amount of automation that I've tried up until now has yielded results that are not always consistent to my expectations. The reason for that high level of manual work is the parsing that I do, depending on what type of list I'm looking at. The code that we programmed is very, very strict So if there's some value in the field and I'm expecting an IP, even if I parse it, it's going to say I'm not going to take it, right? So that forces me to be more insistent on the quality of data, right? So a mixture of automation scripts, Python-based, database queries, looking into the fields, what the data is before I actually implement that, and then manual research, right? So I found also as well, when you tend to use crawlers to capture information, which is what Shodan does, the quality of that information is not always consistent to my expectations, right? And my expectation is if I capture something about an IP, then I assume that that IP is legitimate and that it's active. If I try to ping an IP and it's not there, then my first question is, okay, well, how old is the data? Is it usable? Right? So that's an issue when you're dealing with botnets that are based off of P2P or specifically the flux problem, because domains are coming up left and right. You don't have enough time. Once you finally get the domain, they're gone, then the next domain's there, and then et cetera, right? So one of the workarounds for that problem I found, which was helpful, was using long life-based DNS information. So figuring out what is benign, what isn't benign, creating white and black lists. So the blacklist will be an assistant to your qualification algorithm to test if it's accurate or not. And the whitelist, obviously, you don't want to see those websites. But then, if you think about it, there were talks on DEF CON where we specifically saw attacks about 2 years ago, and also last year that we found in Ukraine, that were basically targeting legitimate domains and hiding behind bulletproof hosting, right? So, grain of salt. I don't know if that answers the question, though. Hopefully it did. Yeah? Okay.
Okay. Here I am. How many questions do I have? One or two?
Depends, right?
Depends.
Each one comes out more.
Okay, the easy one. What you're doing with Shodan? What kind of queries are you doing with Shodan?
Well, with Shodan, I think it was helpful to qualify some of the sensor information I was pulling in. So, for instance, during the attacks that happened a few weeks ago with Telecom, we were seeing an enormous amount of up to 900,000 IPs that were active in botnet networks that were basically attacking port 7547. So if you want to get an idea of Telnet or standard ports or port 7547 for DSL modems, then you'd go to Shodan and you can type in port 7547 just to take a look at what the crawler found on IPs that are actively listening on port 7547. Now, in that instance, it's interesting for a specific threat. If you're looking at social bots, then if you can try to get IP information, which I'm not allowed to get because I'm not law enforcement from Twitter, you have to kind of piece together and correlate the different bits and pieces of information. So if you're lucky, from the Twitter scripts that I have, I don't get the IP. If I'm lucky and they're stupid enough to keep geolocation on, then I have the location at least. And then I can start drilling down with crawlers to find some more information.
Okay.
Not sure if that answers your question, though.
Yes, it does. Thank you. Now, a big picture question. What you learned from the US elections and what can we apply here in Germany?
The most important lessons learned was that elections are very surprising. The second lessons learned is that there was a lot of botnet activity that we observed during election. Whether it was contributed to a nation state or not, I don't know yet because I just don't have enough information to say that confidentially or confidently. It was interesting that the attacks that we saw during election day, November 8th, we saw a substantial amount of attacks going on in specific states. That's all I'm going to say to that. Whether it's related to a bigger campaign, you just have to collect more data. And that's the reason why the algorithms and thinking mathematically separate the emotions and what I want to be true to the information and data that I'm actually collecting, right? So there were a few surprises. That was the third lessons learned. I assumed it was one specific area, but the attacks that happen are way more complex, right? And this whole idea started with when I started seeing comments, and I think as a technical guy, I got way too political, which was a good thing that I got flamed for that, which is awesome. Because it reminded me that I'm supposed to focus in on the logics, on the numbers, on the facts. And for me, the interesting thing was why I got into this in the first place was when there were comments that were really totally stupid and radical, and I commented something, About 5 minutes later, I had various different IPs from Russia, China, Vietnam, etc., hitting my site, trying to do everything from brute force to whatever. And I found that very curious, right? I mean, I'm not proactively hiding myself, but that's how I started getting interested in finding out, okay, well, I got 200 plus Twitter users that followed me within 1 day, and then on November 9th, those 200 users, they just disappeared. And you don't have to be a rocket scientist to figure out that something was going on, right? Who's behind it? I don't know. Yeah. I don't know if that answers the second question. So elections are very interesting, surprising things, full of emotion. Second off, attack data doesn't always give you a clear answer on what you're hoping it does. So to get a clear answer, you have to collect information through various different sources.
Well, we've run out of time. I'm sorry, you'll have to come and
we'll
grab
take
him
them
afterwards.
offline. Okay.
But everyone, let's give Michael a warm round of applause. Thank you.